Okay, so we just finished up talking about how we can have completely within subjects design, where the variables vary completely within subjects. We can have completely between subjects designs, where different subjects get each combination of the levels of the different variables. And we can also have a mixed design that's sort of a bridge between the two, where we have some variables that are varied within subjects and other variables that vary between subjects. Let's take a look at correlational studies and experiments and how they play out with these things. So, correlational study, what happens with the IV, the independent variable? Hopefully you all remember that in a correlational study, all IVs are measured. How about the experiment? Instead of all being measured, all are manipulated. The dependent variable or variables for a correlational study, it's measured. And for an experiment, this is also measured. So those are the same there. So it's really only the measurements thus far that differentiate between correlational studies and experiments. And this is really crucial, right? The whole reason that we prefer experiments when we can do them is that by being able to manipulate a variable, we can randomly assign individuals to participate in different conditions. And it's this random assignment to different conditions that allows us to balance out all of those things. So earlier I talked about having a little caffeine or being a little tired or those other things. And by randomly assigning people to the different conditions, those things should all get balanced out. All right. So, between subjects. Can we do a between subjects correlational study? Well, absolutely. If we want to look at any difference based on religion, ethnicity, gender, political preference, those are all between subjects designs. So, yeah, we can do between subjects designs with correlational studies. For experiments, can we do between subjects designs? And the answer to this is, yeah, absolutely. We just talked about doing an experiment with a completely between subjects design, right? Where each, if you think back about the visual search experiment, where we had different groups participating for feature searches at set size 6 and 12, and also for conjunction searches at set size 6 and 12. So we could do that when we have different groups in each of those conditions, yeah, so we can do between subjects designs with experiments. How about within subjects designs? Can we do something like that with a correlational study? Actually, yeah, you can. So if you think about a developmental study where you're maybe doing a longitudinal design and you're following people over time, you're taking measurements within subjects. So, yep, you can do that. Can we do it with experiments? Yeah. The visual search experiment, we can have all people perform all of those conditions. So, absolutely. How about mixed designs? Well, yeah, if we can do between and we can do within, certainly. So, why am I showing you this? It's important to not think necessarily that, oh, we can only use a correlational study for a between subjects design, because that's not the case. There are going to be some between subjects factors that we can't manipulate that we are going to use correlational studies for. But just by using a between subjects design doesn't necessarily make something correlational. Okay, so if mixed designs are a mixture of between and within subjects designs, is there anything in between measuring all of our independent variables and manipulating all of our independent variables? The answer is yes. We can measure some independent variables and manipulate another set of independent variables. And this type of design would be known as a quasi or quasi experiment. So some are measured and some manipulated. Stop. Clarification time. Okay, so something bugged me a little bit about the way that I presented quasi-experiments. So the basic idea with the quasi-experiment is that we have one or more independent variables that are being measured and one or more independent variables that are being manipulated. So the manipulated refers to the experimental component and the measured ones refers to the correlational component. And while it's true that experiments that have both a manipulation and measurement will necessarily be quasi-experiments, it's also possible that you could have a quasi-experiment where it appears that you have a manipulation. So to clarify this, I pulled out my book by Cook and Campbell, Quasi Experimentation, which is the classic on quasi-experiments. And it says, quasi-experiments, experiments that have treatments, outcome measures, and experimental units, but do not use random assignment to create the comparisons from which treatment cause change is inferred. So it's not just that there's necessarily something that is measured and something that is manipulated. If you make a manipulation but the assignment isn't completely random, you also have a quasi-experiment. Because a true experiment involves some manipulation, which then you use random assignment to assign individuals or whatever it is that you're looking at to the different levels. So imagine that you are interested in improving reading scores for fourth graders. And you come up with an idea to, some intervention to help students read better. And you are going to randomly sample from some population, and then you are going to randomly assign individual students to either receive the treatment or get the control. In this section where you are assigning individual students, and you are looking at how those individual students perform on some later test, you've got an experiment. Woohoo! However, now imagine a situation where you randomly sample a group of fourth grade classes, and you randomly assign half of those classes to the treatment and half of those classes to the control. If you're looking to see if the scores for the classes improve or decrease or are the same for the experimental and control conditions, then you're fine. You still have an experiment. If, however, you are looking at whether or not the students within those classes change, which is another way of looking at things, you're actually doing a quasi-experiment. The difference here doesn't have to do with the manipulation. It has to do with how or which level of analysis you're looking at. Are you looking at the classes or are you looking at the students? In my earlier example, we were randomly assigning students. In this example, we were randomly assigning classes. So if we're looking at classes, we've got an experiment. But if we're looking at individuals in the second case, we don't have a true experiment. Why? Well, because the students within those classes are being randomly assigned. If we have Mrs. Smith's class, everyone in that class either gets the treatment or not. So even though Miss Smith's class or Ms. Smith's class was randomly assigned to a particular condition, the individual students weren't. So if we're looking at performance for the class as a whole, we've got an experiment. If we're looking at performance for individual students, we have a quasi-experiment because we didn't completely randomly assign the individuals that we're actually looking at to see if there's a difference. I hope that makes sense. There's also one other thing that I want to point out that a lot of people get confused about. So some individuals say if there's something like a manipulation. So imagine a situation where you have individuals who have had damage to a particular part of the brain, let's say Wernicke's area, and you're going to compare their language comprehension to individuals who are neurologically intact. Some people would say, well, this is like a natural experiment because nature, the things that happen to these people knocked out their Wernicke's area. However, this isn't an experiment. You didn't randomly assign people to get the brain damage or not. It's not an experiment. In a situation like this, I haven't manipulated anything. Nature may have, but I haven't. And so really, this isn't even a natural, we shouldn't think of it as a natural experiment, because experiment suggests a manipulation that we've made and random assignment. So what type of thing is this? This is just a correlational study. So a good example of a quasi-experiment might be seeing if males and females respond differently to some type of treatment. For example, sexual imagery in advertising. Does it have the same types of effects on males and females when you increase the amount of sexual imagery? So maybe in males, more sex is always better. And maybe in females that's not the case, or maybe it's something else. But in a situation like that, I can manipulate the imagery that I'm showing someone, but I can't manipulate their sex, right? So that would mean that I would have a combination of independent variables that are measured and a combination that are manipulated. Now, for the variables that we're manipulating, random assignment, again, is crucial. It's crucial because it helps balance out those other things. However, because we can't randomly assign everything, any claims that we make about the variable that we're just measuring or interactions of that variable with any of the variables that we're manipulating, we need to be careful about making claims of causation, because since we're not actually manipulating it and we're not randomly assigning people to the variable that we're measuring, we can't really be very sure about causal links. Okay, so the DV here, yeah, it's measured again. Can you guess what this will be? Yeah, this could be between, it could be within, or it could be mixed. Okay, so I said that we can use between, within, or mixed designs when we're doing a quasi-experiment. So let's think about what some different types of quasi-experiments might actually look like. So an example of a quasi-experiment using a between subjects design might be something like looking to see the effectiveness of different types of treatment for depression on males and females. Male and female, that varies between subjects. That's not something that we manipulate, it's something that we just measure. However, treatment is something that we can manipulate. So we can randomly assign half of the depressed individuals who come into a clinic to some new treatment that we think might be more effective into the traditional treatment. So in that situation, we have a manipulation, and we also have a measurement. And both of those are completely between subjects because we aren't going to give the new treatment along with the old treatment at the same time. So how about a fully within subjects design? Well, imagine that we want to look and see how individuals of different ages respond to the Stroop effect. So we get maybe some kids at age 5 and we have them read or name colors. This shouldn't be a big deal because kids can name colors by age 5 even if they're not reading yet. So they can name the colors for incongruent and congruent condition at age 5. We can look and see how they do at age 6, age 7, age 10, age 18. We could look at a number of different ages. In that situation, the variables are varying within subject, right? So age, we're looking at the same subject at age 5 that we're looking at age 10. Also, the congruence and incongruence. We can have the same subjects participate in both of those conditions. Now, we're just measuring age, right? We can't manipulate age. I can't say, poof, you're 10, but I can manipulate which condition that you're in. So we have an experimental component and a correlational component as well. So it's quasi-experiment. Finally, a mixed design, one where we have something that is within participants and something that is between participants. So think about the effects of alcohol on driving ability for males and females. We could do this, right? So males and females, that's a between subjects factor that we can just measure. So that's our measured correlational component. And I can have them drive some obstacle course with no alcohol in their bloodstream. And I can also have them do the same obstacle course after they have a blood alcohol level of some certain amount. So the blood alcohol level is varying within subjects. And that's my manipulation, so we've got a quasi-experiment for mixed too. So don't think just because you have a quasi, that quasi is equivalent with a mixed design. Even though quasi mixes experimental and correlational components, that's different than the type of mixing that's going on here. Here the mixing that's going on is a mixture of between and within subjects designs. Here the mixing is a mixing of correlational experimental techniques.